Hey, hi friends, welcome to my YouTube channel. So today we are going to look at the problem named subset sum problem. So let's go through the statement first. So given an array of positive integers and a value target, determine if there is a subset of given array with sum equal to target. Okay. So for example, this is the array that is given 3, 34, 4, and there is a target given as 9. So if you can say 4 plus 5, right, is 9. So there exists a subset in this array which has a target sum of 9. So our output will be true. Okay, let's take some other example. Let me just a minute. I should set it up earlier, but yeah, just give me a second. Yep. So let's look at it. For example, this was the array 1, 3, 5, 8, 9. First of all are positives, right? So this is clear. And target is, for example, um, say 9. Okay. So there exists a subset, right? So this is the subset which is 9, correct? This is also a subset which is 9. So there could be any, for example, if 9 is not there, sorry, if 9 is not there, so there exists a subset, right? So we can say that 135 is equal to 9. So our answer will be true. Okay, so we need to find this sum in this array, correct? And any number of elements could add up to this target. Okay, and they need not necessarily be into kind of sequence. I mean, any set could be there. For example, 1, then 3, 4, 7, then 5. So this 5, 3, 1, this is also 9, right? So in this case also our answer will be true. I hope you understand the problem. So we need to just return if there exists a subset of target sum in this array or not. So let's look at um, so it's like kind of recursive thing to me. I mean, you could think like, for example, you can either you can consider this or you can't consider this. If you consider this, then for this array you have to figure out a sum of 4. Since like for the, let's see, for the original array, right, you want the sum as 9, correct? But if you consider this element, then how much is pending? 4, right? Now you are looking for a sum in of 4 in this array. If you discard this, then you again look out a sum of 9 in this whole array. So there are only two possibilities, right? So every time, like for example, this is the array that is given, which is having 1 to n. Okay, so here you consider nth element, here you don't consider nth element. Okay, if you consider nth element, your sum will be, now what is the sum you're looking for? You're looking for sum minus ARR of n. Okay, this is the sum that you're looking for. And now your array will be 1 to n minus 1, right? And here if you don't consider this, the sum will remain the same and your array size will get reduced. Okay, so that's the approach I'm thinking. And yeah, it's like every element, once you consider it, and in one side of recursion you are considering it, in another side of the recursion you are not considering it. So your tree will have kind of 2 raised to power n branches, and so your complexity will be order of 2 raised to power n. N is the number, basically size of the array. Okay, let's try to code this first. And okay, for example, this is the scenario. Now I have another method called boolean is subset sum that will be taking an array. Okay, that will be taking kind of the n, I mean, or maybe current index, and that will be taking kind of sum. Correct. For first, I mean, when I am calling this, so I'm calling this with, say, this array and the length of this array, and sum will be the complete sum. Okay, so, or maybe you can say target, right? So this will be the return time. Okay, now what do we do this? What do we do here? If our, so here is some base conditions for recursions, right? First of all, let's look at, so let's first of all consider, go from the last. Okay, consider current index. So if you see, your current index would be, for example, this is the array, right? 1 3 5 7, this is the array, and you need to look for, say, 11 as the sum. Okay, this is the target. Target is 11. Okay, now this is the array, right? Now you consider this element, right? You start from the last. The index is 0 1 2 3, so this third index will start from here. You consider this or you don't consider it. If you consider it, there will be some situation. If you don't consider it, there will be another situation. If you consider this, the sum will be kind of 11 minus 7, that is 4. Now you need to look of target sum 4 inside the remaining array. But if you don't consider it, you keep on looking kind of target sum of 11 inside the remaining array. I hope that is clear. Okay, now is sum set sum. Now we'll have array current index. If we consider this, okay, here we are considering this. Okay, if we consider this, so here sum will be sum minus, you have to look for sum minus current index, sum minus, right? I mean and since we are calling it for array dot length, so I mean, for example, there are 5 elements, so length will be 5, but index would be kind of, last index would be 4, right? So that is the reason I'm subtracting -1, otherwise it will throw me kind of array out of bound. Or if I don't consider it, so I'll look for the sum only. Okay, so this will be kind of my return. Okay, but since all elements are positive, right? I mean, why would I go here? I mean, if this number is greater than sum, right? So I will have kind of a check if sum is less than or equal to array sum is less than array current index -1, then I only return this. Okay, if my sum is less than array of current index -1, right? right? If it is equal, then also I can go ahead and base conditions. So if I got a sum of 0, I should return true. Okay. Yeah. And if I'll reached at 0th index, I mean I've already covered the array and the sum is still not 0, then I should say return false. Right. That should be it. So yeah, that are the base conditions. Yeah, I think that's what should work, I think. Let's try. But yeah, it will be kind of, I mean, time limit exceeded. TLE should be thrown here, but let's try if it is getting executed or not. Okay, so this is a function that is newly added, right? And this is the line that I've added here. Can I run this somehow? Got it. Yeah, it's working, right? Now, if I try to submit it, yeah, finally all the test cases are being passed, but the complexity of the solution is pretty high, right? So we need to optimize it somehow. Okay, so again, as we are kind of saying that we are oscillating on these two things, right? Current index and the sum. So it could happen that, I mean, we start getting these sub problems again. I mean, so so there are two branches, for example, in a recursion. So those two branches are calculating the same sum for the same index. So if we could have calculated it before, so we need not calculate it again. So somehow, if we can think of caching it, let's implement the caching logic. Let's see if we can take a, a memorization array. Okay, that will be of size, say, dot length +1 and target +1. Okay, so this is the memorization array that I have taken. Now this memorization array, no, first of all, let's sort it out. Okay, these two things will be same. If now we can have this memorization array filled with -1s. I mean, fill with, say, -1s. Okay. Now for it may be row wise. If you traverse it, you can say arrays dot fill this row with -1. Okay, that's how you can fill it with -1s. And now you can check, right, if your what is the current index, right? If your current index and the sum is equal -1 is not equal to -1, so you return this thing, right? So basically you're storing kind of zeros and ones here. I'm planning to store 0 and 1. 1 is say 1 means exists. So there exists a target sum in this array. 0 means not exist, not there. Okay. So if it is 1, so that means we'll return it. If it is not, okay, it'll come back here and I'll say okay, if it's true, I'm just working in Kotlin. Let's see. Okay. Okay. Sorry, I'm just forget how to write it. Ternary operator here. Let's see. Ternary operator. So yeah, it's question mark then. Okay. Truth then 1, 0, and yeah. Similarly, we can write here, for example, this is kind of an OR operation, and if its result is then 1 or 0, right? Okay, that's how we just divided that thing. Let's run it now. Copy this thing here and copy this thing here. You're not getting any error, right? What is giving me an error? 42. Oh, should give me an error. Oh, somehow I modified this, but yeah, I changed the signature, right? But somehow it's not there. Let's change it. It's working. Let's submit it. Yep. Now, see, this is one way of writing DP, right? We just memorizing while writing recursion. Okay. Another could be tabular form. So you can convert this into like kind of a tabular DP. Let's see if I mean I'm very used to writing this kind wherein I write first of all recursive code, then I memorize it using an array or any structure, right? So I think you can there exists, I mean, other ways as well wherein you can think directly from the tabular form of DP. I mean, rather than going via recursion route, you can just start with kind of two for loops and you can fill that table. Uh, so yeah, you can think in that direction as well. But yeah, I'm covering, I mean, these two methods right now. That's all from my side, and please share, comment, and yeah, on this video, and let me know how you find it. Thanks a lot.